All right, welcome folks. So continuing the theme of being sort of vaguely philosophical in the last lesson here, I want to continue with something that we're kind of that some of you may have taken for granted, but I really want to focus on what this is saying. So for instance, this statement, L equals 4. Now, certainly we've seen that before, but what does it actually mean? What does this thing mean? What does equals mean? So, equality here, this idea of equality in mathematics, means they represent the same thing in sort of different manners here. So L and 4 here, these two objects, even though they're different, they represent the same idea here. And the way we connect them together is with this thing that we call equals here. So this sort of thing here is known as equals, right? So in a way, it's kind of gluing or relating these two objects together, L and 4. So we have this idea of equality. Right? Now, of course, this isn't the only thing you can write for. This isn't the only way to relate these sorts of objects together. We can rewrite this. We can replace this equality with other things here. For instance, I can write this. This says that L and 4 are related, but this time it's related in a slightly different way. We do this thing we call greater than, so L is bigger than 4, right? We can also do L is less than 4 here, right? So something like that. That's another way of writing this here. We can do this here. This is the term divides, which also means is divisible by. So note that in this situation, what all these things have in common here, this, and this, all of them are taking two objects and sort of joining them together in some fashion here. So this is what we're going to refer to as what is known as a relation here, ladies and gentlemen. So we can define here a relation. As you can see here, we're going to define this as an association between two or more elements of a set here. So as you saw, equality is an example of one, right? It relates two numbers together. Here we have congruence. That's also a relation here that relates two geometric objects together, two segments, two angles. Now, of course, relations don't have to be purely mathematical. They can also be other sorts of relations. So, for instance, is the father up between two people? We can say that that is a relation here. Is as tall as between two objects, right? Two objects can be related if one is as tall as the other here. So, basically, in its most general form, a relation is just associating two objects with one another. Now, there are specific things that are going to go on here when it comes to these sorts of relation things, and I'm going to talk about that here shortly. So, consider the following here. Consider the following here. Certainly 4 is going to be equal to something, right? We can say that 4 is equal to specific things here. We saw that we can say 4 is equal to L, 4 is equal to X, and so on. Now, is there anything that we can put in here that would make this absolutely certain to be true? I mean, certainly you can put 4 equals 2 squared, 4 equals 4, 2 plus 2, but probably the simplest thing you can put in there is 4, right? A number should be equal to itself. And that makes sense here. So notice how in this situation, we have this idea where we have an object being associated with itself here. And this we're going to refer to as what is known as the reflexive property. So this is one of the properties of relations that shows up. We refer to this as what is known as the reflexive property. Any object here is going to be associated with itself. Now, note that not every relation is going to be reflexive. So for instance here, right, we know that 4 equals 4. That's a true statement here, right? So that means in this situation, the reflexive property holds for equality. However, if we try something else, let's say 4 is greater than 4 here. This is a false statement here, unfortunately. So that means in this situation, right, we see that in this situation, reflexive property does not hold for greater than. Whereas over here in the top one, it does hold, right? Because we know there's a true statement here. And this you can replace equality and greater than with anything here. Okay? So you have this idea of reflexive property in this situation here, right? That's the first of the relations we're going to look at. The second relation we're going to be looking at is something known as the symmetric property. If A is associated with B, then B should also be associated with A here. So in this situation, it's kind of like the fact that order doesn't matter. So we can say that, for instance, if 4 equals A, then A equals 4, right? So for equality, you can see here this holds. This is absolutely true here. However, if we say like if 4 is greater than A, then A is greater than 4, right? So notice that basically we're keeping the same relation all the way throughout. We're just simply, in this case, switching the order of the objects here. So the symmetric property is basically asking, does order matter in a relation here? And again, we see that this is false. So in this case here, right, we can see that unlike equality here, where equality we had, in the equality we had reflexive property hold, symmetric property hold, here, for or greater than, reflexive symmetric property fails, right? So you see you have this idea where you have these things that don't work, okay? And that's going to be really important here. The last thing I want to focus on here is what is known as the transitive property. And this may be very familiar to some of you. Basically, the idea behind the transitive property is that you have something that looks like this. If A is associated with B and B is associated with C, then A should be associated with C here. So as an example here with equality, we can do something like this. So for instance, we can say if A equals 4 and 4 equals C, then A equals C, right? I think we can agree this is definitely a true statement here, right? And another thing here, we can see that in this situation, if A equals 4, 4 is equal to C, A is equal to C, that's a true statement here. We can do the same thing with inequality here, right? If A is greater than 4, and 4 is greater than Z, then A is greater than Z here. So we know that this is also true as well. So it's possible for, in this case, we saw that our greater than, it failed the first two properties here, but it passes this third one here. The transitive property holds. So in this case, it's not a complete wash. It's not completely lost here. So we note that this is the case here. Now, note that what we've observed so far is that equality holds all three, right? Reflexive, symmetric, and transitive all work for equality here, whereas for the greater than, only one holds. The transitive property holds here. So the fact that all three of these, reflexive, symmetric, and transitive, all hold for equality means that equality is an important thing here. It shows that the two objects are, basically it's this idea of equality. It shows that these two objects here are sort of the same as each other, right? If you have a relation that doesn't represent this idea of sameness, it won't hold all the properties here. So we refer to this as what is known as an equivalence relation here. We define this idea here. A relation is an equivalence relation if and only if it satisfies the reflexive, symmetric, and transitive properties here. All the properties need to be held in order for this to be called an equivalence relation. So you can see here, equality is an example of an equivalence relation. There are some other equivalence relations out there. I think you can probably show congruence holds too, right? Because congruence is so innately tied to equality here. If equality holds, and certainly congruence should hold as well. And you can see that here. So basically, there's this class of relations that we call equivalence relations, that show that two objects are more or less the same in some fashion here. Now, doesn't apply to everything, of course not here. But the ones that it does apply to, equality and congruence, are going to be the ones that we're going to be using as throughout. And because it applies to all of them, we can actually use these as ideas, and we're going to talk about this here later on. So keep these in mind as we move on here.